Okay, so last week we were having a look at the calculations that you can do with a normal curve. So I just quickly want you to have a look at this normal curve that we've got up here and remind yourself of what you can tell by looking at a normal curve. So what do these numbers mean along the bottom? What information can you take from those numbers? How much can you remember in terms of percentages of how many, what percentage of individuals of our population fit into each different area under the curve. And then I'd like you to focus on this number here, the 115, and I want you to think what percentage of data would fit below the 115 mark. So if I was to draw a line up from 115, what percentage of my data fits into this part of my normal curve? So pause the video here and just think about those two questions. Okay, so the information that you can tell from a normal curve, you should have reminded yourself that this number here is the mean, the middle value. That should be at the highest peak of your normal curve. It should also be the median and the mode, this number here, so it should be mean, median and mode. Each of these numbers here represents a standard deviation, one standard deviation from the mean in either direction, one here and one there, two standard deviations from the mean, one here and one there, and then three standard deviations from the mean shown here. And in terms of remembering the percentages, we should remember that within one standard deviation of the mean either way, we have 68% of our data, which means that one standard deviation one way holds 34% of our data. Two standard deviations from the mean in both directions holds 96% of our data, which means that two standard deviations in one way, so just this area here between 97 and 115, contains 48% of our data. Three standard deviations from the mean, you have 99% of your data falling underneath that stretch of the curve. So in terms of answering question 2 here, well, we know that we're looking for this area below two standard deviations above the mean. So the first thing we should always be thinking is, well, if I'm including this whole area of the graph here, that's 50% of my data. So I know I've definitely got over 50% of my data. The other thing I can be thinking about is, I know that this area here, within two standard deviations of the mean, is 96%. But then if we have a look at this, so the 50% covers this area of the graph here, 96% covers this area of the graph, which means that I've covered this middle area here twice. So I don't want to do that, I just want this half of the 96%. So I split it in half, and I've got 50% here and 48% here. So if we add them together, you get 98% of your data falls below 115. So it's really useful if we look back at this graph that we looked at last lesson. It's useful for you to remember off by heart these percentages. So you should know that 68% of your data falls within one standard deviation of the mean, 96% is within 2, 99% is within 3. You should then remember that these two sections here, between the mean and the first standard deviation, are 34% each. Between the mean and the second standard deviation is 48%, which means that this area here, between this first standard deviation and the second standard deviation, is 14%. The same on the other side here. And then we've got our 2% here and our 2% here to make it up to around about 99% of the data. So it's important to recall those values. If you can remember them, it's going to make your life a lot more quick. So thinking back to last lesson then, the things that we were able to do was what we just did then, calculating the probability of picking someone above or below or between certain numbers. So if I gave you the numbers here, if I said, find me the probability of picking someone with an intelligence score between 85 and 115, you would be able to tell me that there's a 68% probability or a 0.68 probability. We also worked out that you could calculate the expected number of people found above, below or between these numbers. And we did that by working out the probability first of all, and then multiplying the decimal by the total number of individuals included in the study. So say in this experiment here, I had 100 people. So I do 0.68 multiplied by 100, and that would give me 68. And that would tell me that 68 people, had an intelligence score between 85 and 115. What we're going to look at today is if I give you a probability or a percentage for under the curve, and you need to work out which x value that corresponds to. So for instance, if I said to you 50% of people fall below this value, what is the value? Well, if you know it's 50% of people, you know that it is half of your individuals. So you know that it must be the mean value here, 100. So that one's quite easy, but you can be given any area under the curve and be asked to work it out. So we're going to look at exactly how we do this, and we're going to be using our GDCs to do it. So here's an example. Employees from a certain company are paid, on average, $19.50 per hour, with a standard deviation of $2.30 per hour. The hourly pay follows a normal distribution. The bottom 10% of people are paid below which hourly wage? So we're trying to work out what wage the bottom 10% of people are falling below. So how do we do that? Well, with normal distributions, we always start off by drawing the curve. So here we go, here is my beautiful normal distribution. Obviously yours will look much better because it won't be drawn on a computer. So we can see here I've put on my mean in the middle, 1950. Now obviously I should have put on one standard deviation above and one standard deviation below, but I decided not to. I've then coloured in red the bit that I'm interested in. So I'm interested in this number here, which has 10% of the graph beneath it, 10% of the area of the graph beneath it. Okay, so I need to work out what this value here is. I know this value is 1950, I want to know what this value here is. So we're going to do something very similar to what we did last lesson, and we're going to go to second and vars. But instead of going where we went last time, we're going to go to this inv norm. Okay, inverse normal. Now, if you're using the calculator in your hand, then you should see this screen come up. If not, we're going to have to put the details in brackets, but it goes in exactly the same order. Area, mean, and standard deviation. So the important thing to note here is that area must be added as a decimal. For example, in this case, we're interested in the bottom 10%, but I'm not going to put in 10 for the area, I'm going to put in 0.1. Okay, it won't work and it will give you an error message if you put in the percentage. So don't do that, make sure you're always using a decimal. So let's have a look now at what this looks like. For those of you working with a calculator in your hand, this is what you're going to fill in. Otherwise, you're having a look at this. So I'm going to go to second, and I'm going to go to vars, which brings up my distribution menu. Now, we were doing the normal CDF last lesson. This time we're going to go down to InvNorm, inverse normal, and hit enter. Okay, so remember, we need to do area, we need to do it as a decimal. So I want 10%, the bottom 10%, 0.1. Put a comma. I then need to put in the mean, and the mean is 1950, and another comma. And then I need to put in the standard deviation, 230. Close up the brackets and hit enter. And here we go. So this number here on the axis, where the x is here, is 16.55. So that tells me that the bottom 10% of people in this company are being paid less than 16.55 cents per hour. Okay, so that is what information I'm getting from this. If I was to draw it on, this would be 16.55. Okay. You can, of course, always check and see whether you've got it right by going back to second and vars and using your number here, your 16.55, putting it in with the lower boundary of negative 99999, your mean and your standard deviation, and seeing whether or not you come out with 0.1 for the area under the graph. So you can check yourself by basically doing the inverse of what you've just done. Let's look at another example though, because we're looking here at area below, and that's not what they're always going to ask you. Sometimes they'll ask you area above. So here. The last technique only works if you're being asked for area below a certain number. If you're asked, and if you're given, the area above a certain number, then you have to use a slightly different technique. It's only very slight, just involves a small calculation, okay? Because in your calculator, you must always use the area to the left of the value that you are interested in finding for the inverse calculations. So imagine we've got the same company, the same situation, a mean of 1950, a standard deviation of 230, and I want to know this time what value the top 20% of people are being paid over. So I've sketched my graph again, and I've got the mean here, then I've got my x labelled on here, and I'm interested in what value the top 20% of people fall above. So this area under the graph here is 20%. But to find this out, because our calculator only works with areas below, the area that I'm going to use is actually 80%. Because I know the area below this value must be 80%, 100 minus 20. So when I put this into my calculator, I'm going to ask it for the value for which 80% of the data falls below. So let's have a look at what that will look like then. Here we go. So I'm going to go back to my second, back to vars, open up my inverse normal, enter. Okay, so this time the area underneath the graph is 0.8. Remember your decimals. Put in a comma. I need to put in my mean, 1950, and then a comma, and then my standard deviation, which was 230. Okay, and close up the brackets. So this is going to tell me the area, the value, which is above 80% of the data, which is exactly the same as the value which is below 20% of the data. It's the same value. So I'm going to hit enter. And that is $21.44 if we round that up. Okay, so 20% of people in the company are being paid above $21.44. So that X value is 21.44. Okay, make sure that you're happy with how to do those calculations. Make sure you remember that you are always putting in the area to the left-hand side of the value, even if you're being asked or being told about the area to the right-hand side. You need to then work out the area to the left so that your calculator understands what you're asking for. And make sure you are always putting in that area as a decimal and not a percentage. Once you're happy with that, have a go at exercise 5C on page 214, all of the questions, and make sure you are drawing a sketch of what you want to find each time.